can't do the puzzle, so I might as well do some maths. And today's programme is about calculating volume. Now, the volume of a three-dimensional shape is a measure of the amount of space it occupies. And to calculate the volume of a cube, it's easy. It's length multiplied by width multiplied by height.
A cube belongs to a group of objects called prisms, another mathematical term. A prism is a three-dimensional shape that has a constant cross-section along its length. In other words, if you slice it up, all of the shapes will be exactly the same.
Later we'll be showing you how to calculate the volume of different shaped prisms, but first, here's something to get your head around about what prisms actually are.
The word prism comes from the Greek meaning to saw or slice. These three-dimensional objects are all made of polystyrene. This is a rectangular cuboid, a cylinder and a cone. To check out which ones are prisms, all I need to do is slice them up to see which ones have a constant cross-section. So here we go. Let the slicing begin. First, the cuboid. And now slicing it the other way. Slicing it this way, the cuboid slices are all the same. The cross-section is a constant rectangle. And slicing it lengthways also gives a constant cross-section. The cuboid is definitely a prism. Next up, the cylinder. Now, cylinder number 2. With a cylinder, slice it this way, and the cross-section is a constant circle. But what happens if you slice it lengthways? This time, the cross-sections are different sizes, but that doesn't matter, because as long as the cross-sections stay the same in one direction, it's still a prism. So, the cylinder gets the prism thumbs up. And finally, the cone. And to slice the cone this way, you need a bit of help. Slice a cone in this direction, and the cross-section changes. The slices are all circles, but they're different sizes. In fact, whichever way you slice a cone, the cross-section is never constant. So as far as prisms go, the cone gets the thumbs down. To calculate the volume of a prism, there's a simple rule to remember.
The volume equals the area of the constant cross-section multiplied by the length. For some prisms, like cuboids and cylinders, it's written as the volume equals the area of the cross-section multiplied by the height.
For a cuboid, it's pretty simple. If we take this face here as the constant cross-section, we're looking at a rectangle, and the area is the length multiplied by the width. The height of the cuboid is this dimension here. For a cylinder, the constant cross-section is a circle. The area of a circle is pi r squared. And the height of the cylinder is this dimension here. So, how would you go about calculating the volume of this prism? Here's a clue. When the cross-sectional shape is complicated, take a closer look and see if you can divide it up into simpler shapes whose areas are easier to calculate. The volume of a liquid is usually given in litres or millilitres. 1 litre is the same as 1,000 millilitres, so 500 millilitres is the same as half a litre. And this place handles millions of litres of water every day.
This is the Blue Planet Aquarium in Ellesmere Port, with exotic fish from all over the world. Keeping the fish happy and healthy in their artificial environment is their main concern.
Ian, some of these tanks are huge. What sort of volumes of water are we talking about?
Well, our main Caribbean Reef exhibit actually holds 3.8 million litres.
Sounds like a lot of water. How long does it take you to fill it?
Around 4.5 days.
And why is it important to know the volume of water that goes in each tank?
Well, when you're keeping marine fish, obviously you need to add salt to the water, and fish are very sensitive to salt, so we need to know exactly how much is in our tanks to add the correct amount of salt.
The fish tanks here at the Blue Planet come in all shapes and sizes, but if you had a tank at home, it will probably look more like this. It's a prism with a triangle as its constant cross-section. But what is its volume in litres?
Remember, the volume of any prism is the area of its cross-section multiplied by its length.
For my tank, the area of the triangle is half the base times the height. To calculate the area, I'm going to start by drawing an accurate outline of the triangle. I'm going to use this side here as the base of my triangle. So if I measure it, it's 40 centimetres. And the height is this perpendicular distance here. So if I measure it with a set square, that's going from the base to the opposite corner. Centimetres. These are the dimensions of my triangular cross-section. Now I can calculate the area. Half the base multiplied by the height is a half multiplied by 40 multiplied by 20, which is 400 squared centimetres. So the area of the cross-section is 400 squared centimetres. To find the volume of the tank, I need to multiply that figure by the length, or in this case, the height of the tank. The height is 40 centimetres, so 400 multiplied by 40 is 16,000 cubic centimetres. But what is that in litres?
1,000 cubic centimetres is the same as 1 litre. So to convert 16,000 cubic centimetres into litres, divide it by 1,000. And the answer is 16 litres.
I wonder how many of these it would take to fill the big tank around me. It's that part of the programme when we both tackle the same maths question. Jamie, what are you doing behind there?
Well, isn't this programme about prisons?
No, it's about prisms.
Oh, my mistake. One of us will make a deliberate mistake that you've got to spot, so watch carefully to decide if you're going to tick it or trash it.
This shape is the cross-section of a prism 4 metres long. Calculate the volume of the prism, giving your answer to the nearest cubic centimetre. Pens at the ready? Come on, get out of there, let's go.
This shape is the cross-section of a prism 4 metres long. Calculate the volume of the prism, giving your answer to the nearest cubic centimetre.
To calculate the volume of the prism, I first started by calculating the area of this cross-sectional shape, which is called a trapezium. The formula for calculating the area of a trapezium is a half a plus b multiplied by h, where a and b are the parallel sides and h is the distance between them. For this trapezium, the area is half 15 plus 10 multiplied by 25, which gave me 312.5 squared centimetres. The volume of this prism is this area multiplied by the length, which is 4. So the answer is 1,250 cubic centimetres.
I too used the same formula as Katie for working out the area of a trapezium, only I called this side A and this side B. That H we kept the same. Now putting in the figures, that gives me an area of half of 10 plus 15 multiplied by 25, which gave me 312.5 centimetres squared, which is exactly the same as Katie. Only the volume of the prism is the area multiplied by its length, which is 4 metres. That's 400 centimetres. So the answer is 125,000 cubic centimetres. So who's working slick enough to get the tick, and who's going to crash out with the trash?
Is Jamie right with an answer of 125,000 cubic centimetres?
Or is Katie right with an answer of 1,250 cubic centimetres?
OK, it was me that was wrong. I made the common mistake of mixing up my units. The dimensions of this shape are given in centimetres, and the length of the prism is given in metres. To give my answers in centimetres cubed, I should have converted the length of the prism from 4 metres to 400 centimetres.
It's easy to get into tangle with units, so here's something to help you remember how many cubic centimetres there are in a cubic metre. Now, in metres, the volume of this cube is 1 metre multiplied by 1 metre multiplied by 1 metre, which is 1 cubic metre.
In centimetres, it's 100 centimetres multiplied by 100 centimetres multiplied by 100 centimetres, which is 1,000,000 cubic centimetres.
So, if this sugar cube is 1 cubic centimetre, you'd need 1,000,000 of them to build a cube this big. Whew. This is Manchester Airport, one of the UK's busiest. Not only does it fly people all over the world, it also moves massive amounts of cargo. The top half carries passengers, while the bottom half carries cargo and freight. Now, the big empty space where your baggage or the cargo goes is called the hold, and the airline sells this space to anybody that wants to transport anything by air. Space costs money, so to maximise the use of this space, most cargo is packed into containers, like this one. Now, the volume of each container is crucial. This one has been designed to fit snugly into the hold of a 767, and, mathematically, it's a prism. To calculate the volume of a prism, you first need to spot the constant cross-section. For this prism, the cross-section might look complicated, but it can be divided into simpler shapes, 2 trapezia and a rectangle. The area of the rectangle is 5.12 square metres. The area of each trapezium is 0.54 square metres. So the total area of the cross-section is 0.54 plus 5.12 plus 0.54, which is 6.2 square metres. Now finally, to work out the volume, that's the amount of space the container occupies, you need to multiply the cross-sectional area by the length of the prism, which is 2.44 metres, and you'll get your answer in cubic metres. But, a little question for you, how much extra space would you get if the prism was half a metre longer?